All right, we are in Algebra. We are on lesson 12-4. Today's date is Monday, March 18th. So March 18th, 3/18. Please put it on your own papers as well. That way it's a little bit easier to see when things happened. All right, so last Friday, the notes I have from last Friday are right here, and I have Jose and Jessica's if they want to grab theirs. Last Friday we did square roots and cube roots, and now we're going to even farther. So you'll see down here we're going to do fourth roots and fifth roots today. We learned this property on 12-1, our first lesson of Unit 12. If I have x over y, all of that to the power of n, I kind of distribute the power. Can anyone tell me, and I forgot to pass out participation cards as well, who can tell me, or who wants to pass out the participation cards too? Gunnar, you want to do it? Sure. And now who can give me a quiet raised hand and tell me what that property is? Josie. So tell me exactly what to write. N times x, like that? Okay. Over n times y? You're really close, but that's not quite the property. You still get points for trying. So let me come back and give you your points before I forget. So if I come back here to here, Josie, you get points. We'll give it to Jessica.
X to the power of n over 1 to the power.
There it is. So I just move this power here, and I move this power down here. I'm kind of distributing the power. So write that down, just a quick review of that rule. Thank you, Jessica. And both Josie and Jessica can turn in your cards. All right, so using that rule, we can find what happens when we take the square root of a fraction. This fraction is really a power, and I'm going to talk about that not today, but sometime in this unit, maybe tomorrow. What is this going to be, Andres?
I have a question.
You have a question?
Can I use a colored pencil to do one?
Yeah, that's fine.
Because I don't have to.
Hopefully you can erase.
Uh,
So very similar to our rule over here where we distribute this n, this power of n, I'm going to be distributing this square root. Who can tell me what this is equivalent to? If I have the square root of the whole thing, I'm going to only look at the top and the bottom to distribute that square root. Who wants to take a guess at it? Jenny?
Is it 2?
It's a good guess. How'd you get 2?
I don't know. I looked back in the notes and it said like the 2 was hidden.
Oh yeah, so there is a hidden index of 2 here. You are correct. I was trying to simplify the numerator and denominator, but I'll still give you XP because you're right. It is a hidden index of 2. So Jenny, there you are. And you can turn your card too if you want. Yeah, Sergio.
is it 8 over 5?
Oh yeah, you skipped a step and you are totally correct. It is 8 over 5, so thank you, Sergio. And I'm going to show Sergio's work here. Sergio saw that I'm going to take the square root of the top and the square root of the bottom. So this can be rewritten as the square root of 64 on the top, all divided by the square root of 25 on the bottom. And I do end my square roots with this little tail here to come down to let you know that I ended the square root, just because it can be confusing if it's square root of 64x or square root of 64x. You don't know if the x is inside or outside, so that's why I add the little tail there. You don't have to do that though. And then Sergio's next step was saying, okay, well I actually know the square root of 64 because we've memorized it in our last lesson and it's also up on the wall. Square root of 64, Sergio told us was 8, and square root of 25, Sergio told us was 5. And there is our answer. It's 8 over 5. So very similar to this rule where I distribute the power, I'm distributing the square root to the top and the bottom. All right, let's see a quiet raised hand. Who can use our chart up here, or hopefully your memory, to tell me what is the square root of this fraction, this rational expression, 169 divided by 225? I only see 2 hands. I'm going to wait. I only see 2 hands. Again, if you have your card, can you raise your hand with the card so I can give you preference? Yeah, go for it, Eder.
14 over 15.
14 over 15 is indeed correct. Ooh, actually it's close to correct. 14 over 15. One of those 2 numbers is correct, one of them is wrong. You want to give it another shot, Eder? No? All right, Jose.
13 over
13 over 15. Yeah, these two numbers, if you switch those last two numbers, it does turn into 14. But this one is actually 13 over 15. And there's our final answer. So Jose got in. So Jose's card is in. Eder's card is in. Thank you, Eder. All right. So a review of multiplication when you have decimals. Was this 6th grade, 7th grade? It was not too long ago. 8th grade, maybe, for some of us. All right, who can walk me through multiplication with decimals? Who remembers how to do this? Because we all need to remember how to do this in order to go backwards, because we're going backwards today. Anyone remember how to do multiplication? Of course, you get XP for participating every single time. Yeah, for trying to. Yeah, Fernando, go for it.
So you keep the decimal where it is.
Okay.
And you do 2 times 2 and then 2 times 1.
So 2 times 2 right here is 4. 2 times 1 diagonally right here is 2. All right, what do I do next, Fernando?
And then you put a 0.
A 0.
And then 1 times 2.
1 times 2 this direction is 2. 1 times 1 right here is 1. Then what do I do? I do indeed add them. And I get 144. And now the really tricky question, you still get full XP because you did that hard part. Where does the decimal go? Does it go in spot 1 or spot 2? Hold up fingers. I want to see. Everyone take a yes. Spot 1 or spot 2? Where does the decimal go? Interesting, interesting. The correct answer is 1. What? Because the way that you multiply decimals is you count the number of decimal places after the decimal. I have a total of 1, now a total of 2. I add them up, and there are a total of 2 decimal place moves. So I have a total of 2 decimal place moves. It's 1.44. And this is true, again, if I verify it with the calculator. If I do 1, actually, you can't see that in the, okay, move the spotlight search down here. 1.2 times 1.2 is indeed 1.44. So calculator has told us that Mr. Sindel is correct. All right, so if I want to go backwards now. Now I know that this is going to be something point something. Something point something because I have 2 decimal places, which means I should have a total of 1 right here times itself, so another 1. So it's going to be something point something. What is the answer here? By the way, this was on the warm-up. 256, I just moved the decimal on you guys. And 256 is up on the wall up above you too if you want it. The square root of 2.56 is what? Let's take a guess. Fernando has his hand raised. I'm looking for more hands. Monse, do you still have your card?
Yes.
Can I call on you then? Let's go for it. 1.6 is correct. 1.6. So normally the square root of 256 is 16. But because it's 2.56, I move the decimal place once. The general rule of thumb is move the decimal place half the number of times. So that's my key for you guys. Move half the decimal places. So think of 256 without any decimals. The answer was 16. Well, how many decimal places did you move? You moved 1, 2. So move half of that, which is just 1. So I move 1, and it is 1.6. All right. So you will have a homework assignment on taking the square roots of decimals and fractions. That is the first homework assignment, those 2 examples. Our next homework assignment is taking the 4th and 5th roots of things. So instead of doing 2 groups or 3 groups, just like square roots and cube roots, now we're doing 4 groups, and on the back here, 5 groups. So what I want us to do is I want us to write the question that this is actually asking us. I know this is a mathematical equivalency, but it's really asking this question. What times what times what? I can have better handwriting. Times what equals 81. Notice that there are 4 what's here. That's really the question. I can actually have my question mark right there. Notice here that there are 4 different groups. There are 4 whats? 1, 2, 3, 4. There were 4 of these whats. So that means when I have my factor tree, I need my factors in 4 equal groups. So again, just like before when we're doing big square roots, I'm going to start by making a factor tree. 81. Quiet raised hand. What times what? I need 2 factors of 81. I see Josie's hand. I see Sergio's hand. Go for it, Jenny. 9 times 9. Perfect. 9 times 9. That's good, but I still can't get it into 4 equal groups, so I need more factors. Jenny, you want to do it again? What's 9 times 9? Or what's factors of 9? 3 and 3, and we also have 3 and 3. Thank you. All right, Jenny's getting some more XP. So I need to somehow separate these factors into 4 equal groups. Well, since there are only 4 factors, those are the 4 groups. Here's group 1, group 2, group 3, and group 4. I have them into 4 equal groups now, so the answer is 3. If I had other numbers aside from 3, or more numbers, more factors than just those 4 factors, then I would have to do some regrouping. This one was pretty straightforward and nice and easy. Let's see a harder example that you guys will help me with again. All right, so I need to make a factor tree for 256. 256. Quiet raised hand. Who can tell me? Who can help me with this factor tree? Yeah, Gunnar. 16 times 16. All right, and then 16 turns into, careful, that would be 18. 8 times 2. And 8 is 2 times 4. And 4 is 2 times 2. Perfect. And then this one is going to be identical. I'm going to make it parallel. So 2 and 8. 8 was 4 and 2. Oop, I guess if I want to make it parallel, I should do 2 and 4. Doesn't really matter. And then 2 and 2. And then circle all the factors so I can count them up and make sure I cross them off once I regroup them. So we have a lot of 2's. If I list out all of the factors, my factors are, this is going to be equal to 2 times 2 times 2. How many times? I have 1, 2, 3, 4, 1, 2, 3, 4. So I have 8 of these. 1, 2, 3, 4. I don't know what I'm writing there. 4, 5, 6, 7, 8. So I now have all of the factors. Now I need to get these in 4 equal groups. Can someone tell me how to do that? Jose? Say again? Group 2 numbers at a time? Yeah, so 1, 2, 1, 2, 1, 2, 1, 2. So there's the first group, there's the second group, there's the third group, there's the fourth group. Again, we were trying to make 4 groups because asking for the 4th root. So we've made 4 groups, and there's our answer. Our answer is what one of these groups is. One of these groups is 2 times 2, so our answer is 4. We're on the back. All right, 5th roots. All right, someone help me ask the question. This is really asking the question. Sergio.
Something times something times something times something times something.
Yep, you count them up 5 times. And we can actually, instead of saying something or what, we can use a variable, right? Yeah, so let's make it even more precise. We can say x is that something, and then instead of doing times with a cross, I'm going to do dot. So x times x times x times x times x. That's 1, 2, 3, 4, 5 x's equals 32. That's the question. What times what times what times what times what? The same what's. Notice that there are now 5 of these things. There's 5 of them. equals 32. So that means I need 5 groups. So if I need 5 groups, again, you start with your factor tree. Sergio participated. Thank you, Sergio. Who wants to help me with my factor tree for 32? Fernando, go for it.
4 times 8.
4 times 8. Perfect. What are factors of 4?
2 times
Factors of 8.
2 times
And factors of 4.
1.
Circle all the factors. We have 1, 2, 3, 4, 5. Oh, that's kind of nice. There are only 5 factors. So if I need to make them into groups, each of them are their own group. So our answer is 2. Each of these are their own group, so my one group is 2. Let's try a harder example. Oh, I promise you we're going to get into the 4 digits. This is our final example. I'll keep this scrolled up so that you can see. All right. I need to find a factor tree for 1024. 1024. What times what is 1024? And you can start with small numbers. It's okay. Andres?
512 times 2.
Yep. So I'm going to do it 2 times 512. And I forgot to give Fernando his XP. Let's give Andres yours preemptively. What about 512, Andres?
256 times 2.
Yep. 2 times 256. And 256 is?
128 times 2.
128 times 2. So 2 times 128. And 128 is?
64 times 2.
Yep. And 64 is?
32 times 2.
It is 32 times 2. And 32 is?
16 times 2.
Yep. And 16 is?
4 times 4.
4 times 4. And 4 is?
2 times 2.
And the other 4 is also?
2 times 2.
Whew, we got a lot of 2's there. This will lead me to an interesting computer science principle, but let's circle all of our factors. There's a factor, 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 and there are our last 4 factors. Whew! We had a lot of 2's in that factor tree. Let's list them out. How many do we actually have? Let's count them up. We had 1, 2, 3, 4, 5, 6, plus 4 is 10. So this was 2, 10 times. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Whew. Okay, we got all of those 2's. How does that help us find the 5th root of 1024 again? Can someone help me do the final step? I see 2 hands. Sergio?
Could it be like 4?
The answer is 4, yeah. How'd you get 4?
Because like I divide 10 divided by 2, and then I got like 2 groups.
Okay, so
2.
groups of 2?
Yeah.
So 1, 2, 3, 4, 5. Yeah, we have 1 group, 2 groups, 3 groups, 4 groups, 5 groups, and you told us that the answer was one of those groups, which is just what again?
4.
4, yeah.
Could it be also like 2 to the power of 2?
Or 2 to the power of 2, yeah. This is the same thing as 2 to the power of 2. So the answer was 4. That is all the notes I have for you guys. Do you have any questions before you write your summaries? No questions?
Wait,
Yeah, question,
could
Sergio.
it, like got like an odd number, like 11, and I have to get like 5.
Then there is no answer. Yeah, so if you have, Fernando's asking the question like, what if you took the square root of 77? That means I need to have 2 groups because there's a hidden 2 out there, but if I have a factor tree for 77, that's only 7 and 11. There's no possible way to make 2 identical groups. That means that we can't do that. It means it's going to be some decimal. For example, if I actually take the square root of 77, you'll see that it is a weird decimal. So if you can't get equal groups, you have a decimal. And I'll teach you guys eventually how to simplify this rational into something a little bit easier. But for now, just don't worry about it. Question, Fernando.
Do I get a key for asking that question?
What question did you ask?
You said I asked that question.
If I can remember what the question was, then yes.
The one that Sergio just asked you said my name instead of his.
Oh, that is my
That's a teacher.
my bad. Yeah, that is a teacher error. And Andres, did you have a question? What was your question, Andres?
Oh, no, I didn't have a question.
Okay. All right, that concludes the note.